All right, good morning. I'm planning on doing Leetcode contest 289 from last Saturday. All right, so here we go. All right, open these guys up. In a string S consisting of digits and an integer k, a round can be completed if the length of S is greater than k. In one round, you do the following: divide S into consecutive groups of size k. So this is the first k groups, character groups, next k characters groups, or second group k. Note that the size of the last group is smaller. K, that's fine. It's not divisible at k. Place each group of S with string representative of string and sum of all the digits. Okay. Already merge those together to form a new string. Okay. Sounds good. Let's do this. Python. We can recursively split S into K, into I guess chunks. 6:14 a.m. How many minutes for game plan? Right, we can recursively split S into chunks of length K. Add them up. Right? Until S, like length of S is less than, is it less than or equal to? Yes, less than or equal to K. So if length of S is less than or equal to K, return S. Otherwise, we'll split S into K chunks or chunks. Right, everything with K. I think Python, I think Python 3 has a function which splits into chunks K. I think Kotlin has something like that too. Oops, something like that too. Okay, anyhow, that might be something we can clean up. Right, so feature cleanup. Okay. So T equals S dot. Let's just do T is an array. It'll be the transform string. I modulus K is evenly divisible. I is even divisible by K. Then we'll take a chunk of it starting at 1. Starting at 2. K is at least 2. T dot append S I minus K to I non-inclusive. And then one last one. In case of leftovers. If then K, length of S modulus K, right? If it's not evenly divisible by K, I'll take the remainder, right? Mod, if mod, that's how many it goes over by. So t dot append as sub negative to the end, negative mod to the end. Okay, so let's see if we get how many chunks are here. For example, 1, 3, 4, 5, 6, 7, 8, 9, 0, 1. Okay, so length of S equals 11. So how many chunks of 3 are there? Modulus 3. So take a chunk here. Key is 3. Take a chunk there. Take a chunk there. Right, and then 11 modulus 3 equals 2. So take negative 2 from these, it'll take these last 2 chunks. Right, okay, so then t dot map, or actually t equals int s for s in t. We'll just do this a instead of t, it should be fine. Just call this thing an array. An array of integers. Oops, let's do append. Let's just change this thing into an int right here. And then just change it to an integer here too. Okay, so we need to add them up. A equals some of the digits, I guess, right? Some of the digits. Let's do this. F equals S. Individual characters summed. Character integer int. Character minus int 0 for C and S. F. Right, so it'll sum those up and then return self.digit sum A that we want to join to string. Join A. Okay. Okay. Oh, I forget how long that took. Maybe it took like a couple minutes, right? 16 or so. 2 minutes for game plan, and then it was 6:16 a.m. to 6:23 a.m. About 7 minutes for implementation. Okay, let's see what happens. Invalid syntax. Oops. This is not right. F equals lambda s colon. Expected stir instance, I see. Stir x for X and A. $135, that's right. And then 0, 0, 0. Looks okay. Oh, no. Okay. Wrong answer. All right, what happened? Input was 1, 2, 3, 4. Output was 3, but we're expecting 3, 7. Okie dokie. Input's 1, 2, 3, and we split into chunks of 2. Should be 3 and 7. Print A. Oops. 2, 3, 4, and then 2. Okay, let's debug this real quick and then see what else is going on. Oh, I know why, right? Mod. Oh, there's no mod. Okay, so this one is +1 for I non-inclusive, right? +1 for I non-inclusive. Let's do this then. Not that or I equals, do this. N equals length of S. N. Let's just do this. Sum. And C minus int 0. Or, I don't think this is needed. Or Cn. That. Or I equals N. Okay, use the sample test cases. And this one, make sure they're all passed. So all good. 511 is not right. 511 is not right now. So I broke the first test with that change. Yeah, so that part doesn't work. Mod equals in modulus K. If mod a dot append sum int C or Cn S sub negative mod to the end. Okay, that looks good. Yay. Okay, so wrong answer, and then debug plus fix solution. That was from 6:23 to 6:28 a.m. 5 minutes. Okay, so that's not too shabby. I just do this F, right? F sub this guy, and then F sub that guy. Okay, yeah, that looks okay. Stick it up there. Stick it down here, maybe, I don't know. Down here might be okay. Let's move on. Yeah, whatever, we'll do this one in JavaScript. 9:26 a.m. Start. Okay, here we go. Okay, so this one looks like we need 2 or 3 of something in order to reduce it. And we can, I suppose, do the simulation of reductions. Two, 3, or 5. How many minutes for game plan? Okay, so use a map to count each difficulty. Sorry, buckets to consume. We can consume 2 or 3 at a time. So let X be the bucket quantity, be a task difficulty bucket quantity. It's just some arbitrary. If X is right, if X is evenly divisible by 3, then we can consume all 3s greedily, right? It makes sense to take biggest 3, right? Because we want to minimize the the rounds. Complete all the tasks. If X is evenly divisible by 5, then does it make sense to take 3s still? I think so. But I'm not too sure. If X is evenly divisible by 2, then what? only take 2s, maybe. Let's say this is like 10. What's the best way to reduce this? What is the best way to reduce this, right? This is 2 5s, right? 5 plus 5, 2 plus 3 plus 2 plus 3. Is there a better way to do it? I don't think so. This is evenly divisible by 2 and 3, or by 2, oops, by 2, 2 and 5. We take 2 5s. Let's just try different values. How about 1? This is no good. 2 is pretty naive. Naive. It's 2. All right, we take 2. 3 again. Oops. Naive. We take 3. Okay, so 4. I wonder if this is dynamic programming. Maybe we can just do dynamic programming and reduce it. I don't know. I'm trying to get up to it. No, I think I'm making it maybe too hard on myself. I'm gonna keep it super simple, right? Keep it super simple. And here we can see that if you subtract 2, you subtract 3, then it makes sense that we take 2. This is no good, so we make this one like infinity. Cost 1. It's cost infinity. Cost 1. So we can either do 4 minus 3 equals 1, which is 1 plus previous solution, right? 3 away would be this, or 4 minus 2 equals 2, right? Cost 1. All right, so this guy would be cost 2, 5, 3 or 2, 2 or 3. 2 or 3 is same difference. 1 plus cost of 1, cost 2. 6, 3, or 2. Okay, so the recurrence relation seems to be working out from the bottom up. So let's go with it. Okay, 629 to 638. About 9 minutes for the game plan, and then let's do the implementation. 6:38 a.m. minutes for implementation. All right, let's just code it. Basically, we'll go from the bottom up until we get to each of these values. No, we can't do that because it's a billion. It's way too big to do a linear scan of a billion. Okay, which is expected to TLE since X is like less than 1 billion. I guess so. Note, right, the crux of this problem. Reduce X efficiently. Since a linear scan to 1 billion will definitely TLE. Get some more coffee here real quick. I'll be right back. Alrighty. M is a new map. That'll be our counter for let X of A. M dot set X 1 plus get X for 0. Okay, so count those, and then for each of those counts, count the rounds. F will be our function which reduces X. Zero, 1, 2, 3. 0, 1, 2, 3. All right, base cases. While dp.length is less than X, return dp sub X. Okay. A equal, let's see, N equals dp.length. A equal dp okay, so dp dot push 0. A equals dp sub n minus three, and b equal dp sub n minus 2, 2 away or 3 away. dp sub n equals 1 plus math.min of a and b, 2 away or 3 away. Okay. now I'm wondering, does this make sense? Because I know it's definitely not the right way to do a linear scan, but maybe it's good practice. I want to know if I'm not able to reduce it though in the end. It's infinity. Zero and one would be infinity. My question two. So I guess what values are invalid for reduction? Can we reduce all values greater than 1? Maybe. Right? We can do this linear scan, then it does make sense that we can. Yes, I mean, yes, I think so. At least I think so, right? So if it's reducible, like how do you reduce it efficiently, most efficiently? We take the largest chunk of 3s, take the rest as 2s. KISS, right? Keep it super simple. Does it make sense to, all right, just greedily take as many 3s as possible and take remaining 2s? All right, so 10, we can take 9 with 1 left over, so that doesn't work. All right, but 10, we can take the next thing, which is 6, with 4 left over, so that does work, right? Here, this one's no good. This one's cool. Take the biggest chunk of 3 and then go down in a linear scan, maybe? Oh, I see. Maybe we need binary search to reduce search space for optimal number of 3s to consume. Right, so that'd be a logarithmic amount of guesses to reduce 1 billion. Right, that would reduce 1 billion. Without TLE. Well, we already wrote this so far, so let's just say, okay, so T will be our total, which will be our map, each key and value, count, let's count, that map, each count into function of the count. Okay, so if T dot any X x equals infinity, and we'll return -1 in that case, is it? Yeah, -1. Otherwise, return the sum of x, that's t, right? Sum, it's just an array. Sum of a low dash. Okay, let's see what happens. A, it's already been, oops, yeah, A has already been declared. Okay, so it's just the total, whatever. Totals. T dot any or how does this work? Sum, I think. So 2 is not right. Okay, let's see what we got. Log T. Okay, so anyhow, let's see. 6:38 to 6:50. 12 minutes for implementation, and then 6:50 a.m. to whatever it is. Debug plus fix. Right, so this is oops. Wrong answer. Expect 4. 1, 1, and undefined. It's undefined. 1 reduction, 1 reduction. Huh. X, and then DP. Let's do this DP. Zero, 1, 2, 3, 4. 0, 1, 2. 0, 1, 2, 3. 0, 1, 2, 3, 4. One more past X. So if it's 5, then 0, 1, 2, 3, 4, and 5, right? Okay, that looks good. And then this guy should be -1. And then this whole thing is expected to TLE anyhow. All right, okay, so it looks cool. And we could reuse our DP calculations, but it's still like way too slow. This thing's going to TLE for sure. So what I think I need instead of a linear scan is expected TLE, right? Oh, no way. That's accepted? Okay. Whatever. 3 minutes to plug and fix for AC. This is surprising. I was originally expecting TLE. Oh, interesting. So I'm not even reusing this. All right, we can reuse it like this. Just declare it up here and add on to it as we go. This should be way faster this way, right? I think that's way faster. Right, reuse that calculation. Okay, whatever. Let's just keep going. Moving on. How much time we have left? 50 minutes. Okay. So we did Python 3, JavaScript, let's do C++, how about whatever. Okay, oops. 6:54 a.m. minutes for the overall game plan. Okay. Let's see what we got here. Oh, let's see. Let's note this. About 50 minutes left in the contest. Okay. This thing's huge. 10 to the 5th. Okay, so times n is 10 to the 5th. Each value is 1,000. And you're taking the product of these things and trying to find how many zeros it could be. C++ is probably the worst language for this one. I want Python 3 for handling large numbers. So might want to keep in mind that we want to use the long. Okay, so yeah, this one, I don't know. This one looks weird. Go down somewhere. The products. Let's break it down into pieces that are more manageable. Right, so it seems to make sense to perform prefix products for vertical, horizontal, of one calculations. Right. What the heck? Pivot thing. Like pre-calculation of this thing. And the pivot that will go off to the side from that thing. How do you efficiently consider this though? Click path. Yeah, so you take a path, go up and down, and you take a turn. Or you go left, right, and then go up, down. Either way, it doesn't matter. You get to take one turn. Consider them all though. Turn this way, turn that way, turn that way, turn that way. How would you avoid TLE? Trailing zeros. Yeah, I'm kind of clueless on this one. Kind of clueless. This one. Let's move on. Q4. Okay, let's see what we got here. Let's do the last one in Kotlin. How about 6:59 a.m. and it's game plan. All right, there's an array, our string, longest path. Okay, longest path with different adjacent characters. Zero, 1, 3, A, P. What does S have to do with anything? Oh, okay, S is this label, these nodes, these parents, okay. Zero, 1, 1's parent is 0, 2's parent is 0, 3's parent is 1, 4's parent is 1, 5's parent is 2. So left, right doesn't really matter. Two, 0, 3. Wonder if we can we union find? Oh no, it's a path, so it can't be union find, otherwise there'd be a tree. But a path is something that goes down a left subtree and a right subtree. Right, so 203 is also considered 0 as the pivot. It has to start at the root, the path. The path has to be the root, it does not. Okay, so since we can traverse the path up and down, it makes sense to create an adjacency list to transform the tree into a graph. Transform it into a graph. Right, based upon the parents. So each index 0, n minus 1 inclusive. Adjacent data structure. Stick those in there. All right, okay. Then we can perform BFS, right? BFS. And track what's been seen. To find the longest path in linear time. Okay, so that's the game plan. 7:05. About 6 minutes for the game plan. And let's start the implementation. 7:05 a.m. Dash whatever. All right, minutes. Our implementation. I think that makes sense, right? So yeah, let's just get to it. Let's build this thing. Adjacent to commutable map of int to that mutable. Yeah, mutable list integers. I parent let's call it U and V, I guess, right? U and V in a dot width index. Adjacent does not contain U. Adjacent to view builds mutable list of if not adjacent dot contains V, and adjacent to V goes immutable list of int. Okay, and then adjacent to view add V, adjacent to V dot add U. Okay. That's my adjacency list. And then fun go use an integer and go, we'll do the breadth first search per chunk for in 0 until the dot length is in. Yes. And the size. Candidate equals go. Let's just do this BFS. From I, check what's been seen. Seen equals immutable set of int. best bar best equals 0. Return best equals math max best. That's the best candidate, and then this guy will be our Q. Q of integers. Q dot add U. Wait, Q is the interface, right? Q integers equals linked list of U. Okay. Well, 0 is less than Q dot size. K equals Q dot size. Let's do this. Longest path. Count 0. Turn the count. If scene that contains U, we'll just return 0. We already considered that. Scene to add U. U's on the queue. Okay, so far. Let's just do this I. How about this guy I? Call this guy U. VN adjacent to U. If scene doesn't contain V, and S sub U is not equal to S sub V, then we can expand it. Q dot push V scene dot add V. Push V and add V. And increment the count by 1, right? 1 plus count. Yeah, plus count. Whenever you stick something in the queue, you add it to scene and increment the count. -1 should not be used though. All right, so if V equals -1, which it does at the beginning, A dot slice 1 till N. So skip the root. Okay, so implementation, that's about done. 7:14 a.m., 9 minutes. Implementation. Okay, run it, see what happens. And it's not converted to unit. Okay, so I need to return an integer. Okay. contains, and then add contains, runtime error, no pointer exception. Eek. Okay, so there's nothing adjacent to you maybe at some point? Everything should be adjacent to everything else, isn't it? Where's the no pointer exception occurring? Q.size K. Guess this doesn't matter. Okay, so let's just print this out to make sure I know what I'm doing here. Printlen. I don't know if I can just debug print the whole thing or not. I don't think so. Oh, it does work. Okay, cool. So 0 is adjacent to 0, 0, and 1. Oh, oops. With index is incorrect. Okay, so with index is off by 1. Oops. Okay, A with index. Okay, and then we'll skip the first one, I guess, right? So B is -1. If B equals -1, then let's continue. Okay, so those are off by 1. That's 3, so that looks good. Okay, do the other sample test case, and it should be 3 as well. 3 and 3. Okay, so that looks good. Let's see what happens here and submit it. Oof. Okay. Wrong answer. Wrong answer. Due to corner case. A single root value. All right. So if n is equal to 1, then we'll return 1. -1, z. Z is not a valid value of string type. Oh, single tick, double click. Okay. Here we go. 1 looks good. Oh, dang. I was way off on this one. Okay, holy cow. Okay, wrong answer. I was way off on this one. Output's 139, but I expect 17. Yeah, so I'm adding them one at a time without considering it's not a path, right? It's an outward thing. Okay. Okay, yeah. So this is not a correct implementation because this is a web, not a path. And incorrect implementation, right? Okay, so anyhow, let's see, it's got 24 minutes left. Okay, yeah, I'm gonna upsolve this one later. 24 minutes left in the contest to do upsolve later. All right, mainly this is what I need to do. All right, yep, I'm gonna call it a day for now. Catch you next time.